Let's say we have two interesting people, persons A and B. Person A is right 85% of the time, and person B is right 60% of the time. Since person A appears to be smarter than person B, based solely on the frequency of correctness, we should ask ourselves, must person B always follow person A's opinion? Or would it be prudent for person B to argue against person A sometimes? Let's look at all the possible scenarios. We can have both A and B be right, A right and B wrong, A wrong and B right, or both A and B wrong. Those are all of the possibilities, and they're indicated in this chart. We can actually calculate the probability of each of these four scenarios happening quite easily if A and B's opinions aren't interrelated in a certain way. We call that lack of interrelation independence. With independence, the logical term or implies addition, and the logical term and implies multiplication. Going back to our initial percentages and applying these rules, our four possibilities have these four probabilities. I may not be much better at probability than Big Papa Pump Scott Steiner, but at the very least, all the probabilities in this chart should add up to 1, or I'm definitely on the wrong track. At least these are adding up correctly here. Let's clean up some of this information so we can see it better. All of the relevant information is summed up in this chart here. The important numbers here are the orange ones. These are the numbers where person A and person B disagree. The blue numbers we don't need because person A and person B already agree there, and an argument won't happen. To find out when person B should argue with person A, we need to find out the chance person B is right when they both disagree on something. The chances of B being right when A is wrong is 0.09, and the chances they disagree is the sum of both orange numbers. So the chance of B being wrong when there's a disagreement is 0.09 over 0.43, which is approximately 21% of the time here. Again, since I'm not that confident in my conceptual or computational abilities regarding probability, since I only took it for one summer semester years ago, I'll check and make sure that all of my scenarios add up to 1. This doesn't guarantee that I'm right, but at least here I don't immediately detect that I'm wrong. Well, anyway, this method here concludes the percent of the time person B is correct during a disagreement to be 21%. That number is only valid when person A is right 85% of the time and person B is right 60% of the time. So under these circumstances, the less smart person should still argue against the smarter person about 1 out of every 5 disagreements. That would be the rational thing to do. But 4 out of every 5 disagreements, the less smart person should just probably go with the smarter person's opinion. And you can use this same method to calculate how often the less smart person should argue with the smarter person in general, when the initial numbers are different than 85% and 60%. First, you need to estimate the percentage of the time each person is right in general. Then you fill out the right and wrong chart by multiplying the appropriate probabilities together. Then color the disagreements orange, sum them together for the denominator, and pick whichever person you're trying to find out is right as the numerator. That's a quick algorithm for figuring out how often you should argue with somebody, provided you can estimate how often you're correct and how often they're correct. This algorithm brings to mind the idea contained in Ecclesiastes chapter 9, verse 11, which so eloquently tells us that the best doesn't always win. The race is not to the swift, or the battle to the strong, nor does food come to the wise, or wealth to the brilliant, or favor to the learned, but time and chance happen to them all.